we would now during this session talk about the importance of trees and forests in water cycle. Everyone would agree that yes, trees and forests do play a role. The question is how significant. Is it so forceful and so compulsive that you must consider planting of trees and conservation of forests? Is the question. What force do we have of the evidence available to us to suggest that it is forest which cause rain? We have been struggling with these issues. Several generations of foresters have, and despite everyone knowing the connect, somehow denying it at the moment when decision making happens. And gradually now when everyone is seized up with the environmental crises and the focus is building on it and environment is gaining centrality, that is logics, if are put forth and told, informed at appropriate levels, will gain the day for forestry and mankind as a result. Because it is our lives that are at stake now. Planet is gradually becoming unlivable. There are evidences and there is sufficient warming. Science is known, but the political economy of it, the process of decision making that is involved is still paying lesser credence on this than the immediate times in which, say, we have to provide food, shelter, clothing, other facilities which includes now internet. So this is going to be a very light kind of a session in which we are trying to ask questions and trying to give answers to them. These are the questions. The first 5 questions, 4 questions are factual. The answers to them are factual. In the question number 5, we'll try to understand from those facts, is the suggestion correct that forests can determine the distribution of rainfall on the globe? And having considered that suggestion, we'll look at some evidence which is in form of forest biotic pump concept and theory, and we will understand the basis of such forest biotic pump. So forest is a biological pump is the suggestion here. So let us understand what science and scientists are trying to say and why are they saying so is the question. And finally then we'll talk about the forest management approach that can be adopted to deal with water stress in Indian scenario. And most of it is graphics that you are going to see. Not too much of, not of text. Question number 1. How is rain caused? We understand the water cycle. We know water is lost from the terrestrial surface and oceans to the atmosphere through the process of evaporation and transpiration. Such water, when it rises up, and since temperature lapse happens at the rate of more than 6 degrees per kilometer, that here the condensation process happens, the volume goes down, there is sucking of air column, it becomes a low pressure air column here, because of which more winds come from or more evaporation happens, and then precipitation, white cloud, mist. Clouds are nothing but moisture in air. When it comes closer, relative humidity we understand atmosphere has moisture, but as that moisture concentrates on nuclei, cloud forming nuclei, we talk about cloud seeding. This is what cloud seeding is. We put seeds in the atmosphere and water starts to settle on those seeds and it grows. Initially the color is white, and then if the water component becomes heavier, and that the kind of clouds you see in monsoons black clouds. Thereafter, it can no longer hold the water it contains and it rains. So this is simply the cycle of rain. This is hydrological cycle. In some different contexts, you would find that this rain occurring on land surface and initiating the process of erosion, chemical reaction, washing of metals and nutrients, and as they move, reacting on the path, whatever they come across, changing the chemistry of water bodies and everything else happening. Right? So this rain happens, it is caused by evaporation, transpiration, convection and condensation processes. Now let's see what is the role, how much rain do we get, what is the moisture balance on the globe. Moisture source for rainfall or precipitation on Earth. The total ocean evaporation, the moisture that becomes available is 361 trillion meter cube. This is the total being sourced from the oceans. From the oceans. The precipitation which gets back into ocean, it's not that only on land surface rain occurs, it occurs everywhere. So 324 rains over oceans. So the balance of the two, 37 trillion meter cube, remains available which can fall on the terrestrial surface. Right? But we find that on the terrestrial surface, the total rain received is 99 trillion meter cube. So the question is, where from the balance 62 trillion meter cube coming? What is the source of it? Oceans are not source of it, is the suggestion here. So the source of it is the inland water bodies that you have, the evaporation happening from other land surfaces, the water being lost in process of usage, and the transpiration that plants, it occurs in plants. How significant are these sources? We will know. We know the structure of a tree, we know there is a canopy, we know there is a canopy, there is a root system of a tree. We understand that the deep roots, they help in water percolation as well as storage in soil. We understand the canopy has roughness, which means the surface is rough, it's not smooth. So the wind that comes and hits it does not just pass over it, but starts to roll. So as the trees would release moisture through transpiration process, that moisture would tend to remain here, is what the suggestion is. As it rises, you can understand temperature lapse happening and possibility of rain growing. The moisture release through transpiration happens and cloud seeding I just mentioned. Plants release a number of volatile organic compounds and pollens which act as cloud seeds. So you are finding that to cause rain, trees are giving you everything, the water that is necessary and the nuclei that is necessary to do it. Now the only question is, to what extent? That is the only question remaining. And this is a simple diagram, understandable. The basic science which is accepted. No one perhaps is challenging this. So just note this fact also, per unit area, moisture released from tree canopy through transpiration is 2 times that from a water body through evaporation. So a clear water surface, shining sun versus a tree canopy, take the same vertical projection, if you take the same surface area, then tree would lose water twice the amount of water that would otherwise evaporate from surface of a water body per unit area. Because of the leaves, the leaf area index. In case of the trees which make very dense canopies, small leaves, it is up to 10 times of the vertical projection that you would make, which you make use of when you say how much is the canopy density. You make vertical projection and find how much is covered, how much are the holes between trees, and you say 60% area is covered, and hence 0.6 is the canopy density. So if you make vertical projection, if you lay down all leaves, it is 10 times of that. Right? So evaporation from water bodies is lesser than what happens through trees. Evapotranspiration. Right. Consider this now. Question number 3. How is rainfall distributed globally, and which area are arid areas or desert areas? If you look at the scale, you find that this is the maximum rainfall being shown as over 80 inches or over 200 centimeters. You can see the color gradation. The white color that you find here means very low rainfall. You find that here in this desert, this desert, this desert, and everywhere else. The highest kind of rainfall that you find, the most dark blue, you find Western Ghats, Northeast, Congo Basin, Amazonian forest, Southeast Asia is all blue. So this is the rainfall pattern, right? And the arid zone distribution on the globe. Come to the next one, see the distribution of forest. And this is the distribution. The deserts here, here, here. In Australia, very big desert, and dense forest, Amazonian forest, Congo Basin, Siberian, Western Ghats, Northeast, Southeast Asia. Right? Now let us put them together. Now relate water and forest. Say we start from Amazonia. Water, very much. Now just also watch the gradation. The blue color is not darkest at the coast, but much interior into the continent. Much interior into continent. We need to understand why is it so. Look at the Congo Basin. Similarly, the darkest spots are coming 2,000 kilometers into the continent. Similar is the trend everywhere else where you have significant amount of forest, contiguous forest, starting from the coastal area. Right, so let us consider these. Comparison of rainfall in forest areas show the following. 1. High rainfall zones and well forested zones overlap. This is one fact. Second, areas devoid of forest receive lesser or very little rainfall, some of which areas are deserts actually. And then rainfall increases with distance from coast in case of forests of large extent, is what I've been trying to say when I'm saying please watch the change of color for Amazonian forest. So you are gradually finding that where forests are, there is more rain. Question could be rain came first or forest came first, because questions could be raised or anything, and this is a valid question, it's not invalid, right? But for that perhaps we'll have to go back. This earth was born 4.5 billion years ago. Life originated 3.8 billion years ago. A billion is 10 to the power 9. We need to understand when did it so happen that gradually on the terrestrial surface water presence improved, and on the other hand species evolution increased. And what was that optimum time when you started to see plants on the coast, and then gradually more advanced plants, larger plants, vascular plants coming and developing further into the continents. So that gets into in terms of millions of years, right? But today we find the situation is that wherever there are forests, there is rain. Or conversely, wherever there is rain, there is forest. Right? Now, consider this. This is just, I'm mentioning in passing, this is about the leaf area index. And the purple color shows the area that have maximum leaf area index. And those are, we understand, Amazonia, Congo and other forests globally distributed. Right. This is about how much moisture is there in the air in month of January. Typically a January month, distribution of moisture in air, and the orange color indicates moisture. So more orange, more moisture. So in month of January you're finding that distribution of moisture is like this. In month of July, which is monsoon season, you find the distribution of moisture is like this. Higher condensation occurs in higher evaporation zones. So here we are basically trying to see which are the zones where there is higher evapotranspiration. And obviously where there is higher evapotranspiration, which is because of the trees, so we are kind of building it back. Higher evapotranspiration is seen. And we see this is because of trees. And if there is higher evapotranspiration, there would be higher possibility for rainfall. So we are trying to say that trees are causing rain. The question of which came first, though remains, but now what is happening is the question. It is indicating that. Let us see if scientists have been able to formalize this further and understood it in what terms. Now, what does global distribution pattern of rainfall and forest or the tree cover suggest? We observe the following. There is almost perfect overlap of forest areas and rainfall zones. That is one fact. Higher rainfall is received in areas that have extensive forests. So now we have start to talk about the quantum of forests that are necessary in order that they have influence on rainfall. What is the critical area under forest that must be there to cause rainfall? We are getting into that realm now. And no one perhaps know that. Because your capacity to conduct experiments is largely limited to clinics or watersheds of 100 hectare, 200 hectare. You can manipulate them and make observations. But continental scales, still you do not have capacity. So you are making observations from nature as to what is happening. I am making case for nothing. I am just putting facts to you, in order that you can yourself think as to what and how you would want to argue. So, climatologists, they have not accepted this proposition because they think it is the matter of flow of heat, and with such heat, mass of water is also flowing. Right? Climatologists is still wanting to say that. And in present context of environmental crises, even if for a while we grant it to forest, it is in our favor. We could be saving ourselves and the life on earth if you grant it in favor of trees, plants and forests. In terms of, is it climatology that determines rainfall, or the forests are also able to determine the rainfall, cause rainfall? So they are showing simple cycle here that the earth surface, the land surface gets heated up, the air moves up in this column, and to fill this gap, wind from oceans come, which is monsoon you observe. Then when Indian subcontinent gets heated up, the Tibetan plateau also gets a little warmer, and in the Indian Ocean, dipole gets formed, which means in Arabian Sea you have lesser temperature of ocean surface water, and in Bay of Bengal you have high temperature. Then this is dipole, and other phenomena that you are hearing about is El Nino and La Nina that occurs in Pacific Ocean, and that influences monsoon is what we read in the newspaper. So these two things put together, and Indian subcontinent getting heated up causes movement of moisture-laden winds from ocean towards continental surface, and in Western Ghat you receive rain because they say it is orographic rainfall. Winds come and hit the mountains and you get airfall, rainfall, and then just after it there is a rain shadow region. And Tamil Nadu is not receiving rain during northwest, but returning monsoon. Those are the reasons. We understand them like this.
Sir, both may not be mutually exclusive also.
Absolutely.
Forest plays an important role in regulating the temperature also. So that in turn will influence moisture.
Absolutely. So we want wanting to say, give that value or credit to forest.
Yes.
At present, there is no credit being given to forest. We are saying there is a case that you must consider it more seriously. Right. I've been saying, as you move into the continent, the rainfall is increasing. And I said, so for the forest in Brazil, the forest in Congo, and in fact, Siberian also similar phenomenon is observed. This we have already seen. We have put everything together in this slide. If you look at these graphs, look at I. Where is I? Can you locate it for me? I is here. I is here. Look at this map. It is saying that it's a desert. Look at this map. There is no forest here. It says, this graph says, as you move into continent, the quantity of rainfall reduces like this. The quantity of rainfall falls very rapidly as you move into the continent. Is this graph saying? Correct? And we are then trying to say that since, as there are no forests here, so is it happening. Now compare this I to say suppose B. Where is B? Here is B. Here you find there is lot of forest. It says as you move into the continent and up to 2,500 kilometers, the rainfall is going on increasing. What is causing this? If all water is lost just next to the coast, then what is remaining up to 2,500 kilometers is the question. Right. So we are talking about now the water contributed by all inland sources. And in these cases, such inland sources forests. Because we are talking about the continuous forests that are there from coast into the continent in case of Brazil. Right? So there are, I have given some references here. So science is building on it, making observations and trying to articulate through these diagrams so that it becomes easy to understand and appreciate. Right? So we have now known that if there are forests starting from coastal area itself, then into the interior continent, you would expect rainfall increasing. And this is about distribution of water. The question of quantity of water and its availability, both are important. If lots of water is available, but no distribution of which is there, which are the cases of flash floods or undesirable situations. But if quantity is there and is well distributed, then that's what you would want to promote your economy as well as social well-being. So distribution is important, and forests help redistribute water into continental areas. Okay. Now, why are the zones devoid of forests drought prone globally? The question occurs to us. And I am showing two figures here. This figure, now by this time you are well acquainted. In the above figure, we are talking about droughts. The more open or the white color that you see are drought-free areas. And this chart is showing that only Brazilian forest area it is showing. It may be the issue of scales also. If you blow it up, you might find several other pockets which are drought-free. But as the darkness increases from whiteness to lesser white, further less, and very dark, the incidence of drought, classification of the area moves from drought-free to extremely drought-prone. So I'm just saying that such diagrams also exist. People have mapped droughts, people have mapped forests, people have mapped rainfall and found a correlation between them. A relation between them, because correlations are causal. And we are making a causal case for rain, and forest being the cause is what we are asserting. Right. So if forest cover plays only a minor role, then the logical questions are, why high rainfall and large forest areas overlap globally? Now we are asking back the climatologist that if forests are playing only a minor role, why is this? That you have large forest areas and rainfall overlapping. Why the areas devoid of forest are arid, or why the areas devoid of forest are arid or drought prone? Why deforestation leads to depleting rainfall? How do we explain increasing rainfall farther from coastal areas where the landscape has continuous canopy cover? And compare it or support all of this as arising because of the presence of forest. We say the accumulated wisdom from the past, which is rooted in empirical observations, emphasizes that forests attract or cause rain. Now we are coming to final slides. I think we have exceeded the time. We will now talk about what is being put forth as a theory behind this and named as forest biotic pump concept. This picture, which I have already several times mentioned about the first principles of physics, is simply saying this is ocean, this is land, land having forest. Or from oceans, evaporation happens. From land, evaporation and transpiration both happen. The width of the arrows that you see, the blues, is indicating how much quantity of water is involved. So this diagram is saying that much larger quantity of water is involved in case of terrestrial surface having forest compared to open seas. And it is saying similar thing, that such water which is lost to atmosphere rises up, condenses, pulling more moist air from ocean side. So this is the pump. Sucking of this ocean air, moisture-laden air from our oceans into the continent is done by this entity called forest. So forest is acting as a pump, a biological pump, pumping water. You may have heard about the river in atmosphere. That's basically flow of moisture in atmosphere. And this is the river in atmosphere. And this is a much argued science now. This is from peer-reviewed literature. Let me not get into it. Seasonally it is showing as to how does it function. If we try to look at the basis of biotic pump, then we break into physical components and the ecological components. The physical components talk about evaporation and condensation and circulation of the air, and low pressure zone getting formed above the forest areas, which leads to appearance of air flows converging to the condensation centers, and the ecological basis of it is the evapotranspiration of water, the root system which allows for storage and abstraction of moisture, the high leaf area index, the large height of trees which modifies airflow causing a drag, does not let it pass, the tree producing biogenic condensation nuclei are all ecological basis of this happening. If forestry management has to consider this as an approach, emphasizing the importance of